Hello all our friends! About 3 years ago I learned that headphones frequency response measurements are all over the place. They never really represent how the headphones actually sound, so comparing the chart with the headphone sound is a total mess. So today we're gonna try to solve this with a little help from my friends from Dewesoft, and hopefully we'll bring you some value and understanding in how the measurements actually work, how they are performed, and what they actually mean at the end of the day. Coming up! Welcome. Nice to have you here. Thank you very much for coming. Very excited.
Hi, I'm Andrej. I work at Dewesoft and I'm a software engineer.
Hi, my name is Vid. At Dewesoft, I am in charge of acoustics and vibration measurements.
I'm David from OLLO Audio and I work in research and development.
My name is Rok Gulič and I'm the founder of OLLO Audio.
Today we are installing a measurement system and the challenge is to obtain the frequency response for the headphones.
Time to unpack the mysteries.
This is a SIRIUS MINI data acquisition system. It has 4 BNC inputs to which we can connect either microphones or accelerometers. Of course, since we are testing headphones, we will be connecting microphones. It is a very good device, very high dynamic range, 160 dB due to dual core technology, so it's practically made for this kind of measurement in acoustics or vibration. What was in the box beside the data acquisition system? A USB stick with licensing and version of the software, cable to connect the ground, one cable for power and one cable for communication. This is a USB device, so it can be powered directly from the computer, no need for an additional power supply.
This is the Gras artificial ear sound simulator.
The very high standard of quality. It's an industry standard for headphone testing, so from Gras point of view, this is the best you can get.
Alright, so we finally unboxed both of these beautiful devices and now we have a challenge. We have no idea how to put them together. So David over here is gonna sweat a lot. The funny thing about the Gras gear, it's really cool, but unfortunately there is no manual how to assemble it. So we'll try to figure it out on our own. I think there's a lot of brain power here. So the challenge that we are facing is how to do the measurements in a repeatable way. So how to have as little tolerances as possible from one measurement to another. And at the same time, how to have a measurement that actually translates the information to the user. For example, if you see a chart and you see that there's a bit of a bass boost, that should represent how the headphones will sound on your head. And this is not always the case due to differences in measurements.
Of course, one important thing to be able to achieve this is to have a very accurate measurement system which can handle this kind of acoustic tests. So this is where we come in. And another important factor is that we use something that simulates how the human ear actually responds, speaking from the physical aspect. So we are using a simulator from Gras to handle this job, and we are using a data acquisition system from Dewesoft, which has a very high dynamic range. The idea is to create a measurement chain from which we would be able to compute the transfer function, which in essence would represent how the headphone would react to any kind of input. We will be using 2 microphones from the fixture to test headphones to measure on each ear separately, and then we will be sending the controlled signal to the headphones themselves and also measuring this signal, so we will have all of the data needed that at the end we can plot the curve in frequency domain, so to say, and the customer will know, okay, so this is how my headphone will sound at my eardrum if I don't tweak the equalizer at all. Yeah.
I think we should try to sketch this and see how we can connect all these inputs and outputs and everything together. Yep. So let's go.
Yep. Let's try to first start with the data acquisition device, okay? Because this is at the core of everything, let's say. So this will be computing, sending to the computer everything, performing the analog digital conversion, amplifying the signals and so on. These are the headphones, and then we have 2 microphones inside, okay? So from those 2 microphones there will be 2 cables coming each to the designated input on the data acquisition device. So now we will be able to measure exactly at the position where human eardrum inside the ear would otherwise be. Okay, so now we have the response data. And then we also need to send signal to the headphones. So this is the headphone amp. So it's sending, for example, white noise. So this is what is powering the headphones. And then we need to take the signal from the amplifier and also send it to the data acquisition system. So now on the PC, where we run the software, we will be able to compute the transfer function for each ear individually, because we know exactly what kind of signal is exciting the headphones, and we can also measure the response directly from the microphone.
On the software side, we're running
Dewesoft X3.
So now let's try to put that into real world, connect all the cables and see if it works.
Sure, let's do it.
All right, so now we're gonna connect everything together. So the guys from Dewesoft, Vid and Andrej, together with David, they're gonna try to connect the PC with a SIRIUS Mini. They're gonna put this together, and then we're hopefully gonna be able to connect it with the Gras 45cc and make the first measurements.
Okay.
So we finally set it all up. Vid over here from Dewesoft helped us out a lot. We've learned so much from you guys. So what did we achieve?
In a relatively short time we were able to set everything up, like you said.
Yeah.
We did some measurements already, so the responses are good. They are up to the expectations, but the work will not stop here, of course, for you guys and for us. We will support you. In the future we will try to use the results that we have now and the new system to tweak the responses even further and to have the sound as best as possible.
Beautiful. So a lot coming up from OLLO, and hopefully Dewesoft will be our partner in the future as well. And you guys will soon, in the next vlogs, learn how to use these measurements and what they actually mean. Cheers.